Hello everyone, we are going to see the Vito's family's code. So first let's see the what is the problem statement actually. The problem statement here is the world-known gangster Vito Deadstone is moving to the New York. He has a very big family there, all of them living in the Lamafia Avenue. Since he will visit all his relatives very often, he is trying to find a house close to them. Vito wants to minimize the total distance to all of them and has blackmailed you as you are the programmer or a developer to write a program to that solves his problem. So his problem is to find the minimal distance from his house, but he is not getting any idea. So for that we have given the input format, that is the input consists of several test cases. The first line contains the number of test cases. For each test case you will be given the integer number of relatives, that is how many relatives are there actually. And so the relatives number is greater than 0 but less than 500, and the street numbers where the relatives lives, on which street the relative lives, is given by the uh, is also given by the integers, and the street number is greater than 0 but less than 30,000, and we have given the note that the several, that is many of his relatives live in the same street number. The output format is that for each test case, our program must write this minimal sum of distances from the original Vito's house to each one of his relatives. The distance between two street numbers, that is SI and SJ, is DI of Dij is equals to mod of SI minus SJ. The sample input is given as 224, 324, 346. Here 2 is the number of test cases and this 2 is the number of relatives, and this is the street numbers of these two relatives, and this is the second test case, this is first test case, this is first test case, this is second test case. In second test case we have given the number of relatives 3, and these are the street numbers of the three relatives, and we have found out the output for the minimal distance in which street. In the first test case we have given the minimal distance as 4, and in second test case we have given the minimal distance as, sorry, in first test case we have given the minimal distance as 2, and in second test case we have given the minimal distance as 4. So this is all about the problem statement of the Bitwas family. So let's see how the logic works. So here, suppose I have taken 1 as a test cases and the 4 as the number of the relatives, and these are the street numbers where these 4 relatives live. In this we can see that the number of street numbers are even. So there may be chances that the uh, median of this is maybe 6 or maybe 4, we are not sure, but so I have taken here median as a 6 to find the minimal distance. So we have a formula that is s of I minus s of j. So let us consider s of I as a 6 and s of j means all these street numbers, we have to minus them and then add them. So I have taken here 6 minus 2 plus 6 minus 4 plus 6 minus 6. Now 6 minus 8. Okay. So let's see what is the answer. Equals to 6 minus 2 is 4 plus 6 minus 4 2 plus 6 minus 6 0 plus 6 minus 8 is minus 2, but we don't have to consider here negative value, so I am writing here 2 which is non-negative positive value. So the answer here becomes 4 plus 2 plus 0 plus 2, which is equals to 8. So the minimal distance is the 8. So let's see how the code works. This is the logic behind or whatever the problem that we have seen for the Vito's minimal distance, and now see how the code works. So guys, this is a code where I have defined a function named as the minimal distance, where t is the number of test cases which we are taking from the user. Then for underscore in range of t, then the data is a list in the map, so we have split it. Then r is the number of relatives, so the data of zeroth index. Here, the data of zeroth index is considered as the R, that is the number of relatives, and streets are considered from the index number 1 to so on. Further, are considered as the uh, further all are considered as the street numbers. So they are sorted in ascending order. Then the median equals to street R by uh, 2, which is a floor division to avoid any point. Means we want the median in the format of uh, integer values. So to find distance, I have written the sum of absolute mid minus s for s in streets. That is median minus the street numbers, and we have to sum it. As we have said, we have to sum them, and then the minimal distance that is stored in the distance can be calculated. So let's see how the code works. This is all about the code. So I am just running the code. So see here we have to give the test cases. Suppose I am giving the test cases number as 3. Let's see what's happened. Then they are saying me to give them the number of streets. So as we have seen earlier in the problem statement, we have to as a relative number, then 2 and 4 as a street number. So let's see what is the exactly output of this median. It is 2 or it is something different.